Welcome back to the continuation of our linear homogeneous higher order differential equations with constant coefficients. So far, with all the examples I've taken you through, they were of general solutions. It means there was no conditions attached to the problems. In this next example, I'm taking particular solutions. And I hope by now you understand what particular solution means. It means there are some conditions attached. These conditions can be initial conditions or they can be boundary conditions. So let's take the example here. We are asked to find a general solution to the problem. That's now the order here is the third order. It is also linear. As you can see, it is written of the form yn plus p of yn minus 1 plus p of yn minus 2 through to the last part p of y is equal to 0. It is linear. It is also homogeneous. Why? Because the gt is equal to 0. And then the coefficients, they are constant coefficients. Because we have 1, we have 7, we have we have 4, -7, and -10. They are constant coefficients. So I can go ahead and use the root solution. You realize that in using the root solution, I'll simply have the auxiliary equation as, if you are smart enough and the more you work these things out, you get to know a pattern, that it will just be a simple substitution of the powers. Lambda cubed plus 4 lambda squared minus 7 lambda minus 10 should be equal to 0. Then I can find the root. The root is going to be lambda minus 1, lambda plus 2, lambda minus 5. This will be the roots of the equations. It means that we'll have lambda equal to -1, lambda equal to 2, and then lambda equal to -5. So lambda 1, let me get the standing well done. Okay, so these are my roots. Now classifying these roots in their classifications, they are real and distinct. So what will be my general solution? It will be y of t is equal to c1 e negative t plus c2 e 2t plus c3. Now position of this, I forgot to say in the earlier videos, position of this root does not really matter. So someone can have lambda 1 to be the -5, lambda 2 to be -1, and lambda 3 to be 2. What matters is how you write the solution out. It must go in hand. Right. So with this question, we are not done because we have some conditions attached. And what are these conditions? We had 3 conditions because the highest order is 3. So we need 3 conditions to have a unique solution. This means you must find solution of C1, C2, C3 using the conditions. So my solution, I will write it here. You realize that I will need the first derivative. What is the derivative here? I get -C1. That this is differentiation, so it shouldn't be so hard to do. Okay. And then I also need a second derivative. So I'll quickly do that. I'm going to get C1 of that. I just hope I'm correct with everything. Okay. This is my derivatives. I'm done. Now I have to substitute the conditions in. So at the first point, no, it's equal to -3. I'll use a different color. At -3, I'm going to get -3 is equal to, it means wherever I see t, I place what 0. So that'll be C1 plus C2 plus C3. Then at y prime is equal to 12, I'll have as 12 is equal to, you know that the exponential of 0 is 1. So wherever I see t, I substitute 0. So I'm going to get -C1. And then the last part as the y prime as 0 equal to -36. I'm going to get 36 is equal to C1, 4C2, 25C3. So I have 3 equations to solve. Equation 1, 2, and 3. Any way you want to solve this system of equations is up to you. As I always say in class, there are many ways of killing a cat, and that is the beauty of mathematics. There are many ways to arrive at the same answer or solution. So you can use elimination method, you can use substitution method, or the matrix approach. If I'm going by the matrix approach, that means I have to write out the coefficients here. 1, 1, 1, -1 to -5, 1, 4, 25. And then the variables here is C1, C2, C3 is equal to -3, 12, -36. Please, you are good to use any approach you want. If I'm using a system of equations, I have this. And x becomes A inverse of B. This matrix. So I find the inverse of the matrix A. If here is A, here is X, and here is B. I find the inverse of A and multiply by B. You realize that if you should do this, you're going to get a solution of, let me check my calculator here. I have -5 on 2 for the first one, and then I have 1 for the second, and then -3 on 2 for the last answer. It means this is C1, this is C2, and this is C3. With this, I can write my particular solution, so PS, as the JS was C1e negative lambda, or negative T, C2, let me check, I had it as the 2, 4C2. Oh no, it's just C2, 2 to the power, sorry for that. And then the last was -5t. So I just do a quick substitution to get my particular solution. C1, you know it is -5 on 2. C2, you know it is 1, so it just becomes simply that. C3, you know it is -3 on 2, and then I have that. And so this is my particular solution. It means at any given t, I can find a particular solution. This is the general, this is the particular. So this is how we use the initial conditions given. Always first try and get your derivatives respect to the conditions given, so you can easily do the substitution. I hope this is well understood. Okay, and that brings us to the end of solving the higher order homogeneous linear constant coefficients. That's so much to say, but I hope all the videos should help you out. Thank you.